Hey, what's up, everybody? It's Saim Safdar, and you are listening to the CloudNative.fm podcast. I'm excited and thrilled to host this show for you. This is episode number 12 of CloudNative.fm podcast. Today is April the 30th, 2021, and in this episode, we are going to talk about service mesh production best practices with Linkerd, and also we're going to talk about is Linkerd Mesh with GitOps with my guest Jason Morgan. Jason is a continuous delivery enthusiast who is focused on ensuring that the app that will get released into the production are easy to maintain, monitor, and scale. Jason currently works for Buoyant as a technical evangelist, and prior to Buoyant, Jason has spent more than 3 years as a senior platform architect at VMware. So want to see what he is up to? Follow him on Twitter or Jason Morgan. And let's go ahead and say hi to Jason and cut it over to the interview. Thank you everyone for joining us today. This is CloudNative.fm episode number 11, and today we are talking about the service mesh best practices with Linkerd, and also we try to elaborate this context of is the Linkerd mesh with GitOps, and that I think the topic of interest to everyone today's world, because GitOps is a go-to way for every business, every enterprise is looking for. But tonight I'm really happy for my guest Jason Morgan, and he is a technical evangelist at Buoyant. Buoyant is a maker of Linkerd. How are you, Buoyant? Hired with you, Jason?
Hey, I'm doing real well, thanks, and thanks for having me back. Very excited to talk GitOps and Linkerd because it's obviously something that I've been writing about and working on lately, and I think the more we share about it, the better off we'll be. So.
And also, can you introduce yourself a bit to our audience, where you started your career as a cloud native, how you evolved to the cloud native stuff, where you've been before the Buoyant company, and how you introduced to the service mesh in general?
Yeah, absolutely. So it's a longish story that I'll try and keep short. So I got into computers at all like when I was a young man. I joined the Army, and I got a little bit tricked by an Army recruiter and ended up going into communications, and I learned a lot about computing and networking and stuff through the Army. And after I got done with that, I decided to go and pursue a career in computing. And around 2013, I think I saw that like Docker was becoming a thing and seemed very interesting, and I was very interested in infrastructure and automation, and Docker seemed like a good kind of next step, like a good way to like get some of the value that you see in virtual machines with less load and more predictability. So started there. I ended up in my younger days building a very small internal container orchestration system. From there, I moved to a company called DigitalGlobe, satellite imagery company out of Colorado. And they actually had a pretty mature platform for microservices. They actually ran a satellite on microservices in 2016, I think, somewhere around there. Anyway, got exposed to Cloud Foundry, got exposed to Rancher, which I just thought was fantastic. And I got to really pursue, my big passion, which was continuous integration, continuous delivery around the container space, which is a weird thing to get excited about, but it's what I get excited about. I love, making computers do things in an automated, repeatable fashion. So fast forward from there, I left DigitalGlobe to go to Pivotal, and Pivotal was the Cloud Foundry company. They're also the Spring Boot company, if you're familiar with that. And Pivotal got acquired by VMware. I was very big about talking about Kubernetes and those kind of concepts. I'd seen the need for a service mesh when I was at DigitalGlobe, because we used to maintain these these big libraries that would slow down application development so that folks could get things like encrypted communication between apps or service discovery or circuit breaking or whatever that might be. And anywho, left VMware, earlier this year, and came over to Buoyant so that I could talk about Linkerd full time.
Yes, definitely. It's a wonderful story for you. Have a very broad experience of different cognitive companies as the things are going to evolving because we are living in the containers age right now. Everything is moving to the containers world. We don't have this kind of a notion of today that is work on my machine, but it's not work on the JSON machine. Thanks to the containers and the Docker, it brings up the power of us. And now we are working entirely on the container every day, talking about these kind of stuff. So how's your current role in the Buoyant? What you can do in the Buoyant in the current role you already have right now?
Yeah, so my job is to help folks in the community adopt Linkerd, to talk to partners and integrators about why Linkerd is good and why they should use it, and just in general try and educate folks. Obviously, we met because you had me on Cloud Native Islamabad to talk about Linkerd, and that's kind of my role, is go around and just share the story of why Linkerd is good and why it's easy. And more specifically, I think to some degree, right? Like I feel like I really, one thing I love about the job is I get to go out there and show folks why and how like adopting a service mesh can actually be really easy and straightforward. Like I was just looking on Slack today and we had someone come on Slack and be like, hey, I really, I want to try out Linkerd, but like it's really important to me that I know how to configure MTLS because I want mutual TLS between our applications. And they're like, how do I get that going with Linkerd? Well, it's like install it and add your services to the mesh, and you're done. You've got MTLS right there, and that's the entire story, right? And showing folks that the barrier to entry and the time to value with something like Linkerd can be extremely low.
Yes, definitely. And I think if everybody listening to us today, and if you're watching this from YouTube channel, I think you Cloud Native Islamabad have you covered with Jason is already presented a talk on Linkerd 101, an introduction to the service mesh, and it's very, very cool when you get to know how easy it is to run a cluster in the Linkerd, and everything is spun up in just a few amount of time. And also we have a deep dive session as well. Linkerd 2.10 release is coming up, and you can watch those anytime, as many times you want it. So the first question from everything, I think everybody who's listening to us, they want to understand what the service mesh is and why do we need it if I don't already have it?
Yeah, so a service mesh is really, let me put myself together here. A service mesh is a tool that you install in an environment that allows you to provide some cross-cutting benefits to your applications without changing application code. A service mesh is generally comprised of two main components, a control plane and a data plane. Right? A control plane is that like command and control infrastructure that gives you like a user interface, gives you the ability to set policy, gives you the ability to provide instructions to your apps. And the data plane is made up of a bunch of little proxies that sit beside your applications and communicate with one another, right? So though the communication of those proxies and the fact that they intercept the traffic between your applications make up the data plane, and they do whatever things the control plane tells them to do, right? Like provide things like MTLS, like provide metrics about your app, right? So if you've got a bunch of apps that you haven't like instrumented a common metrics endpoint, if you add them to a mesh, right, like you've got common metrics for absolutely every application. Like give you the ability to inspect traffic. There's others, right? Add timeouts to given calls. I won't dive into all the functionality, but a service mesh is that. It's a tool you install in a Kubernetes cluster that connects your services together via a network of proxies.
Yes, definitely. I think when you got introduced to the Kubernetes and the containers orchestrator world, you have this leverage to this concept called sidecar. And what the sidecar does is putting all the application logic that you previously wrote in order to do the in order to do the canary rollout or doc launch deployment or the blue game deployment, you can wrote into your code. Now you can wrote all that logic inside the sidecar, and that sidecar is managed by somebody else, and that somebody else is a service mesh company or something that's product that's encapsulate all the logic of doing this canary rollout, doc launch deployment, blue game deployment in a very easy way. In that way, your code is not bloated in a very huge amount of lines of code you need to implement it. So I think the first fundamental question that I think when you heard about service meshes, people coming up them on what this sidecar is, and also the people are also thinking about if I another orchestrator like I don't have a Nomad orchestrator or some Docker Swarm. So what this sidecar is, or this sidecar functionality is available on all other orchestrators as well. So if I manage to deploy this service mesh in other orchestrator platforms.
Yeah, so just gonna full disclosure, I've never worked with Nomad, so I don't have any insight into how Nomad works. I know that the folks that make Nomad, HashiCorp, they've got this console service mesh, which I'm sure provides you a way to use a service mesh with Nomad. I can tell you, like, so I used Docker Swarm and Cloud Foundry before I moved to Kubernetes, right? And I was, my last big technical bet was that no one was going to adopt Kubernetes because Docker Swarm is obviously so much better. So I don't make technical predictions anymore. But in Kubernetes, you have a really cool construct that enables some patterns that you don't see in other places. And the construct is called a pod, right? So a pod, instead of being like a single container, is actually like any number of containers that share the same like logical space. So you can share a volume between two containers in a pod. You share a network namespace between two containers in a pod, right? So you have the ability to launch containers together, right? Which is what enabled the idea of a sidecar pattern, right? So like when you hear the word sidecar, like I think, you got a motorcycle and you've got the little like bucket attached to it with the wheel, and you have the person or dog or whatever that can sit in the sidecar, and you've got the person driving, right? And so that's what they're trying to like evoke with that name. So the idea of a sidecar pattern is I have my application container, maybe it's my Flask app, maybe it's my Spring Boot app, whatever that may be, and it communicates out onto the network, right? And with a service mesh, what we do is we put a proxy right beside that application, and that proxy intercepts all the communications in and out of that app and then does stuff to them, right? But that's the focus, right? So anyway, sidecar is unique, or at least comes out of Kubernetes. And I can't tell you what other schedulers are doing today. I know Cloud Foundry didn't have anything like that when I left, right? And they were looking at how were they going to provide mesh style functionality to folks in that space. And I certainly, when last I played with Docker Swarm, which was a while ago, that wasn't a thing that they had.
Yes, definitely. I think Kubernetes has this construct of the pod that you brought up the topic of the pod, the pod is actually a shared volume, the shared space that the container are using that in order to do effectively. And then we have a leverage of running sidecar pattern in it, running service mesh style stuff in it, and that is very easy. And that's giving the intentions of so many companies to build something called the service mesh. And what do you think? What are the primary goals of the service mesh as of today, and what is going on in moving forward?
Yeah, so it's you're gonna get a different answer depending on who you talk to. But in my view, like the primary goal of the service mesh is to take logic and take code that for a long time resided directly inside your applications, out of the applications, and put them into this infrastructure layer thing, right? So take concerns that are really operational concerns, like circuit breaking, like service discovery, like MTLS, like metrics, and put them in the hands of the platform operators, right? So that application developers get to do more of what they need to do, which is focus on application logic, or like generating business value, right? Like, so if you're the person writing your Spring Boot app, right, like you get to focus on, translating business logic into code. And if you're a platform operator, you have the confidence that no matter what that operator wrote or what language they wrote it in, you're going to get common metrics. You're going to hit enterprise standards, and you're going to be able to provide visibility back to those developers, right, without them having to do anything. So, when the time comes to update your service discovery engine or to rotate certificates because your root CA is expired, right? Like, you don't have to go interact with a number of development teams in order to get them to change things. You can instead just do it at the platform layer. Does that make sense?
Yes, definitely. I think the topic, because we are right now is moving from the three-layer architecture, traditional three-layer architecture that we used to work with, is now the microservices architecture. And in the microservice architecture, I think you have a front end, you have a back end, you have a database, and I think you have might be replicas of three replicas of front end, four replicas of might be the back end, and two back replicas of database. So how the traffic eventually goes is the front end talk to the back end, and then back end is talk to the database. And if imagine something goes wrong at it, where actually is going to be happen there? So that's the service visibility or service discovery we're talking about with the service mesh, and how the timing is take place to talk to the front end to the back end, and back end to the database, how much time it takes to travel your request to goes on. I think these are the primary concern of microservice application right now in 2021. And then the next topic is that people are asking that we're just having some sidecar in it, and now we have the service mesh, also called the management plane, or called the data plane, or control plane, we call it the control plane. What are the languages their control planes are written it? What are their primary roles in the service mesh landscape, and what they're trying to solve? What are you trying to do these control planes?
Yeah, so I'm only going to answer for Linkerd, right? Because I'm not qualified to talk about the other meshes. But so for Linkerd, the control plane that ships with the install is written in Golang, right? Which is a very modern language written by Google. Or originally created by Google. It's very big in the Kubernetes and Docker space, and it provides a lot of really good functionality, right? And that works well for the control plane because its operations don't directly sit in the path of your application traffic, right? The data plane, on the other hand, in Linkerd, right, that proxy is actually, it's called special custom built proxy written for Linkerd, called the Linkerd 2 proxy, and it's written in Rust. So Rust is a very modern language. You see a lot of really interesting development happening in that space, both around, not both, around, the way drivers work, network communication, a lot of modern cloud native stuff is beginning to occur in Rust because it compiles to very fast code. So it's a native language, right? So it compiles directly into machine language and can be executed very quickly. And it's also got something that it's really unique. So it's not garbage collected, but it's still memory safe, right? So garbage collection is the process of basically a language looking at how your memory is being used. And if it's got some garbage or some junk in there, it cleans it up, right? So it automatically handles your memory, which works well for most things. But if you're very sensitive to latency, it's a problem, right? So like a proxy that's handling all your application traffic that you don't want to have lose any packets, right? Like if it begins to do garbage collection, you'll start losing things in that time because the app's busy doing something else, right? But so it's bad. It's bad in that sense, right? But it's good because it keeps you more memory safe. Well, Rust has some guarantees in the compiler that will ensure that you stay fairly memory safe when you use it, especially compared to C or C++. Sorry, that was kind of a rambly answer, but short answer is go for the control plane, Rust for the data plane. And we think that Rust is a particularly good language. And the reason we chose it was to ensure that Linkerd would stay the fastest and most secure mesh that's available.
Yes, definitely. I think you answered my next question, that why is Linkerd decided to go for the another instead of integrating the Envoy proxy, they call it Linkerd that's written in the Rust language. And also, I think the one of the founder of Linkerd and Buoyant, William Morgan, has written a blog post about it because so many people are asking about why you decided to do that, and he can also remove the curtain why when you did. I think in the Envoy world, there's you can do so many things, but the Linkerd Rust proxy has a specific. They're trying to do this things that the service mesh need to solve, not doing some extra work there, but it's trying to do this, solve the piece of problem at your hand. And that's why it's very lightweight and very fast way in memory efficient. There are so many other advantages in it. And also,
yeah, so I'm sorry.
Yes, you can say.
Yeah, so to be clear, right, like I think Envoy is great, right? Like right now I'm working on a presentation for the folks that make the emissary gateway, which is an Envoy-based ingress, right? Or the emissary ingress, which is an Envoy-based ingress, right? That does a lot of stuff. And Envoy is a great general purpose proxy, right? But the goal with Linkerd is to keep the whole thing really simple. And like I told you that story earlier about, the person that came on was like, hey, how do I do MTLS? It's like, don't worry about it, man. Like it's just going to work, right? So the goal again is keep it so that if you go learn Linkerd, like you've been using Linkerd for a while, right? Like how often do you interact with the Linkerd proxy? Do you know how to do it like a filter for the Linkerd proxy? Like, probably not. Like I don't, right? Because I don't need to, because you just don't interact with it because the control plane handles everything you need around the proxy because it's very simple, right? Like Envoy's filter chains are important and valuable and make a big impact in the way it works, right? But it's also complex, and you don't necessarily need that just for that service to service communication, right? So that's what we're shooting for.
Yeah.
So trying to walk that line, right? Envoy's great. Go ahead and use it for stuff. For Linkerd to stay as simple and lightweight as it was, we really needed to write our own proxy. And like the other great thing is being written in Rust, it's small, it's simple, it's memory safe, right? Like, so we think we also stay more secure, which is just pretty nice.
Yeah, and also the next question, I think that's a topic of interest to everyone right now. What the multi-cluster is, and do Linkerd is support multi-cluster thing, and also I think this term is called federated cluster. So these are supported by Linkerd, and how the full functioning is happening in a multi-cluster setup.
Yeah, so there's a really short answer to your question, which is yes, Linkerd supports multi-cluster, right? So you can connect the service mesh on one cluster to the service mesh on another cluster, right? The longer answer is there's actually some really cool work being done around, making, like it's a SIG multi-cluster working group inside Kubernetes. It's working on constructs to, extend Kubernetes clusters or whatever, extend like management to multiple Kubernetes clusters. And that's still going and evolving, and Linkerd is going to keep an eye on that and respect that as it matures, right? So that you can easily, span a service between multiple clusters. So today you can span a service between clusters with Linkerd's multi-cluster implementation. Expect over time that that's going to change as like the community practice around multi-cluster changes.
Okay, and definitely, I think there is so many 2.10 release have these kind of some new changes around multi-cluster setup as well.
It does, and 2.11 is going to have more changes. So if you get a chance to watch the Linkerd community calls, there, Oliver Gould gave a little bit of a snippet of how multi-cluster is going to change in 2.11 to support headless services. So like if you're doing, like a big thing is if you're like Yugabyte, right? And you've got a stateful set for your database. You want maybe like 3 nodes of your stateful set in one cluster and 3 nodes in another cluster. So you need a headless Kubernetes service so that you can just go and find which node you want to talk to, right? So that's evolving as time goes forward. But yeah, multi-cluster is an extension in 2.10. So like when you install, it's kind of a longer story, but in the 2.10 release, Linkerd broke the control plane out into kind of that bare minimum control plane that you need to run the cluster. Then every other component was a separate extension. One of those extensions is multi-cluster. which is what allows for that. Hey, let's have an app in one cluster talk to an app in another cluster, or let's have a backend span 2 clusters and share some traffic between each one.
Yeah, and also I think the next question is, I think that's people are, I think, interesting to hear about. I see a Buoyant cloud is popping up in the community, in the Linkerd community. What that is, what problem they try to solve, and how it is moving inside the Linkerd community.
Yeah, so great question. So Buoyant, Buoyant hasn't sold like an enterprise Linkerd, right? But Buoyant's a company that like is out there to make money, get customers, pay for folks to do the continued engineering work that they're doing. And Buoyant Cloud represents our commercial product in this space. So Buoyant Cloud is an extension that you can install to your Linkerd Mesh that will connect it up to a free hosted dashboard. It's a SaaS service from Buoyant, so that you can get some insight into your applications, into what's going on. You can view when your application changes or you do a rollout, right? You can see those events and kind of correlate things between apps as that occurs. So it's a value add service that plugs into Linkerd, but it's not Linkerd Enterprise, right? That makes sense?
Yeah. So I can see of it that everything open source has some open source offering, and on top of it we have some enterprise offering that you have to pay for these kinds of services. And these enterprise offerings are having so many added functionalities in it in order to you pay for it. So I think that is a Buoyant cloud actually is, if you want to learn. Or yeah.
So just to contradict you, Buoyant Cloud is not Linkerd Enterprise, right? Like Linkerd already is an enterprise fully usable version, right? Buoyant Cloud is an entirely separate service that if you're using Linkerd might be appealing to you, right? And you can go try it out. It's totally free to use it up to a certain number of instances, and it's cool and it's its own thing. But just want to be super clear on this. There is no enterprise version of Linkerd. There are no features from Buoyant Cloud that are going to get released into Linkerd over time. Like they are separate products, right?
Yeah.
Buoyant Cloud will just will plug into Linkerd. Sorry about that. I didn't mean to step on you. Just it's a very important distinction for us.
Yes, definitely. I think a lot of people are confused about it, but to really remove the confusion, that's very true. Awesome. I heard about people saying these kind of stuff. So it's really a very good clarification on these kind of stuff. So before we're moving to the GitOps word, I think the new thing that I see is very interesting in the Linkerd extensions. And where you see what the extensions are and where they are going in moving in next releases of Linkerd.
Yeah, so another great question. Thanks. So the goal here, right, is with the design principle with Linkerd is keep it as simple as you possibly can in order to deliver value, right? And we saw it in 2.9, we made it so that you could take the Prometheus that was installed with Linkerd and remove it so someone could bring their own Prometheus, right? Well, turns out not everybody needs a dashboard, right? Not only do you not necessarily want to use the built-in Prometheus, you might not want the dashboard. You might not want, if you're not doing distributed tracing, why would you install Jaeger components, right? So what 2.10 does is breaks up everything in the control plane into its own extension, so that installing the dashboard is a separate install command, like Linkerd viz install instead of Linkerd install. Installing Jaeger is Linkerd Jaeger install. Multicluster was always kind of like a bit of a one-off install. So we just took Multicluster and made it a formal extension so that each one of these can be developed on their own schedule and release on their own cadence, right? But you still get all that velocity around the control plane, and you keep it as minimal as possible. And it gives the opportunity for someone like Buoyant or like Ambassador or whoever wants, right, to write their own extensions, which installs a component that integrates directly with Linkerd.
Yes.
So that's the goal there.
Yeah. I also talk about, I think right now we see that Kubernetes it's a kind of, we have to go about that for in the Linkerd community to start this conversation. I think with the extensions, I see that where it's going right now, because I see the Linkerd in the Kubernetes 1.22 or 20 is 21 pod securities policies are going to be deprecated. And if that's deprecated, if somebody has to do that. If we have extensions, let's say we have a solution for that, Kyverno and open policy agent. So let's say the sidecar, without if routing the traffic to the application, they see if the pod have some PSP, pod security policy sets in. If not, might be Linkerd your service export are injecting those up on the fly, and they are just inside the pod in it. So I think that might be Linkerd extensions another way of doing that. But I started this conversation with other folks in the Linkerd guys as well. Is this a good idea or a bad? But I think there is so many other options as well for Linkerd extensions. And I think extensions are the future in Linkerd as well.
Yeah, so it's definitely going to be the way we go, adding new functionality into Linkerd so that you keep that control plane as minimal as you possibly can. Whether like if I wanted to write, a controller that like took my pod security policies and automatically rewrote them as like OPA rules or something, did some weird transform inside the Kubernetes API, would I do that as an extension, or would I do it just as like a job or whatever? Like, I don't know. I couldn't tell you what the right pathway was. Like in general, right? Like the nice thing about Kubernetes is you can usually follow somebody in the community. So like I'd see what other folks are doing around that first and follow that pattern. Linkerd extensions really are for something that you want tightly integrated with Linkerd, right? Like, I was wondering the other day, like, hey, would it be cool to do like an ingress as a Linkerd extension? Like maybe, or maybe you just like have like a, I'm going to be working with the Linkerd service mesh switch on your ingress install, and you could go at it from either direction.
Yes, definitely. I think Ingress APIs, gateways, and other these kind of stuff are the very good way, very good adoption to the Linkerd extensions as well. So now we'll finally talk about what the GitOps is and how is the GitOps how a Linkerd mesh with the GitOps, what GitOps is, and that's a topic of interest for I think everyone.
Yeah, thanks for that. So I actually wrote an article that with a bit of a goofy title about does a service mesh work well with GitOps? And I thought that pun was really solid. So thanks. So GitOps is great, right? So GitOps is, just for those that don't know, is the concept that you take all of the objects that represent your environment, right? So everything that represents the Kubernetes cluster and what's in the Kubernetes cluster, you put it inside a Git repo, and then you automatically reconcile that Git repo with your kube cluster, right? So because you can represent everything in YAML or JSON or whatever, right, you can sync those two things. So you can see, on your kube cluster, hey, is there anything here? Is there anything that's in the Git repo that's missing here? Okay, let's make it. Is there anything that is here that's not in the Git repo? Okay, let's delete it, or okay, let's alert someone. And I first read about GitOps in like 2016, 15. So I at this point, everything's like the other day. So I learned about it the other day from this article by the folks at Weave about how they were using this thing they called GitOps to manage their clusters, right? And I was like, this is super awesome. I'm going to use it to control Cloud Foundry, and actually made a pretty workable GitOps flow for Cloud Foundry. Fast forward to today, right now, 2021, there is really good tooling around syncing Git repos with Kubernetes clusters, and they're really good and mature practices, right? And there are, I think, two big open source tools that I'm familiar with, right? You've got the GitOps toolkit, largely by the folks over at Weave, and you've got Argo and all the Argo tools that are, I think, originally from the folks over at Intuit, but now I think it's all sorts of folks that are contributing. I was looking the other day, there's like Red Hat folks, and I'm sure there were others, and I don't mean to dismiss anyone. My memory is not fantastic. Sorry, tangent. The the short answer is yeah, it works great, right? So Linkerd works well with the GitOps flow. So it's made so that you can easily install Linkerd as part of a GitOps flow, so that the Linkerd CLI just defaults to outputting a bunch of YAML that you can just save right into a Git repo. The example I have in the article that you referenced at the beginning, that shows you just kind of applying it directly. One thing that a lot of folks that are doing a lot of GitOps work do is they use a tool called Sealed Secrets from the folks over at Bitnami, or formerly Bitnami, now VMware, that allows you to encrypt secrets, Kubernetes secrets objects, store them in Git, and then decrypt them when they get to the Kubernetes cluster, so that you don't ever have to worry about putting passwords or certificates directly in GitHub. Anyway, that workflow works great. They're great examples of people in the community doing it. So you've got the ability to do your like whatever you want to call it, platform or runtime for Kubernetes via GitOps flow. The other nice thing is with Linkerd, the process of getting your apps into the mesh, right? People like probably see in demos, they see folks running the Linkerd inject command, which will look at a deployment and add an annotation. But like, to be clear, you can just add that annotation directly in the YAML. It's just a little tag that says Linkerd inject :enabled, and that's the whole story, right? So you can put it directly on your YAML files in the Git repo. You can put it on your namespace in the repo, right? Whatever you want to do. But it's a great mature flow, and there's a lot of good examples out there.
Yes, definitely. I think the Wave team realized that at the end of the day, Kubernetes is generating the YAML files, and these YAML files can be versioned inside the GitHub repo. And once this file is going to be changing, there is a time for you to spin up a new cluster with new updated version of it. And the WeWork has got this idea. It's very exciting. Plenty of people love about it. And right now we are moving in the GitOps world. We are moving from DevOps to the GitOps world right now. So I think the next question, obvious question for the people who are listening to us, once we achieve the GitOps flow with the Linkerd, what are the responsibilities of the team? What is managed by the dev team or testing team and prod team? What are these responsibilities for the operator and the dev teams are? Can you elaborate this a bit?
Yeah, absolutely. So I'm going to give you a weaselly answer, and I'm sorry, but it's going to depend on your organization, right? Like, so for some folks, you'll have dev teams that do it all, right? Fully integrated. They do dev, on call, operations, CI/CD, right? Like every bit of it. Other organizations will have dedicated platform teams in general, right? Like I see the service mesh and the Kubernetes clusters as a platform level concern. So it's an operator role, whether that's staffed by operators or developers, I have no opinion on, right? And your organization, can do things your own way, but if you're putting things in buckets in your brain, right? Like this is an operational concern about your platform. For the CI/CD pipeline, right? So GitOps, right, is really part of that continuous delivery, right? So you've got continuous integration, which gets your code, builds it, tests it, maybe does integration tests, whatever that may be. At some point, it becomes a little fuzzy, like where are you going from CI to CD? In general, like I look at it as, continuous integration goes from code commit to an artifact in an artifact store that's ready to be tested, by the delivery system, but that's just my definition. It's not some official one. Rambling again. I think CI/CD is a mixed operational and developer concern, right? Like it needs to reflect the needs of your development community, and it needs to reflect the needs of your operators. It needs to reflect the needs of your security folks. Like I used to talk about it all the time. Like CI/CD, in my mind, is all about programmatically representing the interests of everyone in your organization that cares about the way you deliver code, right? Like in a great CI system or CD system or both, right? Like is really good at, or the people that run it are really good at understanding what people want and empathizing with their needs and finding a way to codify them, I guess quite literally, into code. Does that help? I can re-say it if that works.
No, definitely. I think it's going to be very awesome that you're explaining all these concepts in a way, because I think teams are struggling that if we spun up a GitOps flow in the current environment, what is going to be the responsibility of dev? What is going to be the responsibility of the prod team or the platform owners? What are I think right now this is the primary concerns of the companies and enterprises who are adopting the GitOps flow. But I think this is a moving forward for everyone right now, because everyone is putting their code in the GitOps, and if everything is managed by the GitOps, this is an awesome way to do clustering and service mesh things and other kind of things, other cool kind of things. I think
Yeah.
we do a lot of 60 degree of service mesh and these kind of GitOps flow. So the last few question, what is the Linkerd is going up? Is the roadmap, or kind of how is next few months or the 6 months, what is going to be happening inside the Linkerd and the GitOps things, and what you are interested in this your current role?
Yeah, great question. So just a quick heads up, the roadmap for Linkerd is now actually being published and maintained in the Linkerd 2 repo. So there's a roadmap.markdown file, right, or .md. So it's a markdown file which talks about the roadmap. We heard today that a lot of the concerns coming forward in Linkerd are, one, supporting, obviously continue to support our customers' use cases, right? So do things like support headless services in Multicluster, but more specifically, right, what we're looking to do is begin to enforce policy inside Linkerd. So server-side policy, like, hey, should I accept requests from service A or service B? Client-side policy, right, about, hey, at what point should I like, whatever, like do something on my call to a server, like, inject default, or, not do it if that thing's under a certain amount of load, or whatever you're thinking. So there was that, and I can actually look over at our meeting notes, but those are the big ones. It's policy, it's better multi-cluster, and the whole time keeping an eye on, making very few things to configure. There's going to be some stuff about, deprecating types, right? So service profiles are a big part of Linkerd. They add a lot of value to folks, right? But they're old, right? So at some point that API is going to get deprecated in favor of new custom resource definitions. But we want to ensure that as we do it, we don't like force anyone to learn a bunch of new ways of working, right? And we don't force anyone to use a bunch of custom resource definitions just to get value out of Linkerd.
Yes, I think if now we're talking about that right now, is Linkerd is looking for your feedback. The roadmap is public, and they are looking for your feedback. What you are interested in the next features of Linkerd, what you want to see in the Linkerd. So I think that's roadmap public mean that's now you are heard by the Linkerd community. I think I try to put the link on the YouTube channel here, and you can grab it and show what you like to see in the Linkerd next releases. That's the whole point of the public roadmap. And also what you are trying to do in the coming up in the next 6 months in this year. I think we are COVID, everyone is going to be containerized in their home. And there is not a sidecar with us, but what you are trying to do in the next 6 months?
Yeah, well, one, thanks for the question. Get good at, get good at this role, right? Get good at being an evangelist, really do a good job. I'll tell you, one thing we'd love to see is folks that are using Linkerd in production, like, let us know, right? Let us know on Slack, let us know by joining our adopters list. I'm trying to go out there and find folks that are adopting and help tell their story, right? Because we've seen every time I've talked to a Linkerd adopter, I've gotten a really powerful story that we can share with the community and with folks about how using a service mesh doesn't have to be hard, doesn't have to be complicated, doesn't have to involve outages, right? And getting that out there. So we're looking to, I'm personally looking to, talk a lot more. I guess I like talking, if I'm being honest, and and then to help folks that have stories around this to tell those stories and share them out.
Also, I think if you're wrapping up all things up, that's Linkerd steering community, what it is and what the aims are. I think Linkerd steering community is the best place to join. You share your stories in it, what you do.
So the Linkerd steering committee is just that, right? It's helping to drive the direction of the product. So that's not just Buoyant, right? Like Buoyant engineers are doing a lot of the work within Linkerd, but like it's not just our product, right? It's a CNCF product or project. And, you know,
Yes, you can.
Hey, can you hear me now?
Yes, I can hear you.
I can't hear you. Oh, you're muted.
Oh. Yes, I can hear you. You can continue.
All right.
Linkerd steering.
Yeah, awesome. So just to recap, right? Like the steering committee is made up of folks that have adopted Linkerd in production. If you're a production user of Linkerd and you're interested in driving the roadmap, you can apply to be part of the talk. You know, in general, no matter what, we'd love to hear from you. But yeah, it's really the body responsible for deciding, you know, what is the direction of the project as it evolves.
Yes, I think, and Linkerd, I think one of the few communities, one of the best community that I know that are people are very supportive and kind enough to help you. And also they are also running a program that every month you decide to give a community have a Linkerd Hero of the Month, and really appreciated that you nominated me for April as well. And I also, anyone who are doing this kind of stuff like running a podcast or doing some kind of blog post about it or helping others to elaborate on what they can do with the service mesh Linkerd, do share with us. Might be chances are you're the next Linkerd Hero of the Month, and that's the beauty of the Linkerd community. So your stuff is going to be recognized by the world that you are doing good job, and we recognize you all the time. And that is a part of Linkerd community as well. So I try to put all the links to our Linkerd Slack channel and all the Linkerd details in our YouTube channel. And also I try to share Linkerd is mesh with GitOps, the JSON article that we are talking about today. You can read more about it that. But I hope you can enjoy the conversation with us today, and you hope you learn so many cool stuff from you. I try to catch up again Jason Morgan in the future. He's a very good guy. He'll always be very happy and supportive to come share his time with me. He's done 2 sessions with Linkerd in Cloud Islamabad community. I think I highly recommend you to watch those. I think it gives you the feelings of what we're talking about, how it's actually going to look in real world. And that's we cover in our Linkerd Cloud Islamabad 2 session on Linkerd. It's grab the link from YouTube and watch it as many times as you want. And Jason, thank you very much for joining me today. I really learned so many cool stuff from you, and I really watch you. His speaking style is wonderful. Also, the Cloud Islamabad community is telling me there's the Jason's teaching style is very wonderful. It's easy to grasp new concept with the way he presented. So keep up the stuff that you are currently doing, and we hopefully to catch up you again in the future as well. Bye bye. Hey everybody, if you want to keep up what's going on in the cloud native ecosystem, we have a weekly podcast show on YouTube and SoundCloud by the name of Cloud Native Islamabad. You can listen for free every single week. We try to find cloud and cloud native experts, share updates on cloud native best practices, cloud native real-world use cases, cloud native deployment patterns, cloud native deployment strategies. Topics include AKS on Azure, EKS on AWS, GKE on GCP, cloud native architectures, cloud native application developments, container containerizing application, DevOps and automation, cloud native certification strategies, cloud native career tips, and more. So if that sounds awesome to you, head over to the SoundCloud and YouTube and subscribe to Cloud Native Islamabad.